Hello everyone, welcome to AI Anytime channel. In today's video, we are going to build a smart chatbot using ChatGPT, Langchain and Deeplake. I hope you are already familiar with OpenAI's ChatGPT and Langchain, but our focus will be on Deeplake. So Deeplake is again a platform that helps you with the vector databases, but it's not like a traditional vector database that we have seen with Pinecone and others, right? It fits across multimodal, so you have any kind of data that can be video, audio, images or text. That's what Deeplake does, guys. It's completely serverless. Okay, so you don't have to focus more on the management part of it as well. It helps you with the fine tuning as well. And you can also use, I think they have some free plans as well that we can leverage up to some, I think some GB of data, but there are limitations as well in the free version. So we'll be focusing more on Deeplake in this video, that how we can integrate Deeplake with Langchain, and we can also maybe leverage OpenAI's GPT 3.5 Turbo, or we can also use ChatGPT APIs there to build a chatbot there. So the chatbot that we are going to build will be in Streamlit. So we are going to also use a library called Streamlit Chat. Okay, that's also built by someone in community. Again, we'll review that once we start writing our code. So if you see here, currently I'm on Deeplake, which is by activeloop.ai, and it says store anything, deploy anywhere, fine tune your LLM models. I'm more interested in the differentiator here. So if you come down, you will see how Deeplake compares to Pinecone, ChromaDB or VV8, okay, or any other vector databases that we have seen, right? It's, if you see the feature, the first of all is the multimodality, because we are talking about multimodal. That's what GPT-4 supports, or most of the new LLM that we have, the system that, right, they support multimodalities of data. If you would have seen earlier, like ChatGPT was text in, text out, right? So you enter text, you get the text in response, right? Earlier when it started, but now you will see there are a lot of plugins, and now GPT-4 as a large language model kind of supports multimodalities there, right? So it's multimodal. You can see Pinecone, Chroma kind of don't support it yet, and you can fine tune on your data using Deeplake as well, and they're completely serverless. But we talk about Pinecone, you have to manage services. In Chroma, it's a self-hosted kind of available as a native. You can use it natively wherever you want to use that. You can also visualize. I think in Jupyter Notebook it's db.visualize or something. We'll see that in terminal. And it's version control. It's open source as well. So Deeplake is also open source. They have a GitHub repository as well, I guess. So if you click here, it's right Deeplake GitHub. You can also see that here. Database for AI, right? It's very catchy tagline there from Deeplake. Deeplake, database for AI. So we're talking about all things AI here. So different type of data that we have. It fits across. You can see embeddings on audio, text, video, images, PDF, annotations, etc. So labeling also you can work around it. And they have some common data sets like Cypher 10, MNIST, NIH, chest X-ray data. So they have many of those data available on their hub as well. You can explore that. We are not interested in that right now. We are more interested in how we can integrate this with our the most famous library when we talk about generative AI ecosystem, Langchain. So how we can use Langchain integration with Deeplake and combine that with ChatGPT to build a smart chatbot. So you can see here it's on active loop. You can do a click on login. You can see, right, enterprises are also using it, guys. It's not only for developers, but a lot of enterprises they are also using this. 6K GitHub stars, 90 plus contributors, community members. There is a strong community. You can see Metaport working with them. They're also working with Airbus, Intel, and others as well. So this is their website. You can have a look at that website. I'll give the link in the description for that one. Now let's move to the dashboard. So I'm already logged in here in my dashboard. You can see a couple of things that are important for you. If you're coming for the first time on the dashboard, you have to click on create API token. So when you click on API token, it will ask you to create a token. So I'm not going to create that because I already have done that. I have stored the token in my env file. I'll show that the folder directory what I'm talking about. Now here are a few interesting things. You have a tab here called build LLM applications, and there's another tab called train deep learning models, because they have default data. So if I click on this, you see connect existing Deeplake data. So if you come on public data set, right, let me just show you what I'm talking about. So in public datasets, they have multiple datasets available. You can see MNIST, you can see Cypher, you can see Coco training dataset, ImageNet. You want to train image classification model, you want to train object detection model. You can leverage this dataset directly on the hub. Like this basically is a cloud, guys. Okay, so they use multiple. They have some cloud backend. You can look that on AWS and GCP and etc. For example. Okay, so we are more interested in the dataset. So if you click on that, let me go back to home. Now here on this dashboard, you say you don't have any dataset in this organization yet. Please create a dataset using the onboarding steps above. We'll create that programmatically, guys. How we can define kind of an dataset path, and it will automatically create that on your dashboard if that does not exist, okay, earlier. And let me talk about Langchain, guys. So just going through Langchain, and this is what I came across. Okay, very interesting basically information that I wanted to share. If you see the Langchain star history since December last year, you can see the most used library currently on GitHub in the generative AI ecosystem. There is no other library who kind of competes with Langchain at this moment. That's Langchain. The power of Langchain does all the heavy lifting for us, right? And we are going to use Langchain for data pre-processing, for different type of chain. You can also use for prompting, etc. You can see these are different ways we can leverage Langchain. So for models, because it has integration with LLMs there, then you can define custom prompts. You have prompts. You can have multiple chains like retrieval QA, conversational chains, etc. Then you have inbuilt kind of a memory which is more related to context. Okay, memory, I think the word, that's the only word I have little concerned with right now. I'm not in favor of using this word when we're talking about AI kind of having a memory right now, which kind of, I don't know, maybe you have to, if we look at the research from academia, we are still far from memory, right? But anyway, and then we have agent. So we have agent GPT, right? For example, with Langchain integration. So you would have seen with SERP API, etc., Wikipedia, Wiki API and all, right? So here is the GitHub repository. There was something about Langchain. Let's start writing the code. I'm more interested in writing the code, guys. So what I'm going to do here, let me just show you a folder structure. I have created a folder called Deeplake question answering QA. Okay, basically a QA bot that we are going to create here, and I already have a virtual environment. So I'm just going to activate that virtual environment. So I'm just going inside venv scripts, and I'm just going to activate this. So /activate as I'm on PowerShell. Okay, and couple of cd dot to go into the root directory, clear, and I'm opening the VS Code here. So code dot. Okay, so these are the requirements, guys. We need Langchain, Deeplake, OpenAI, tick token, Streamlit Chat. So let me just give you an overview of Streamlit Chat. We have to give credit to the community, right? The guy who has created that. All the credit goes to them. Okay, whoever has created. So you can see used by contributor. There are 6 contributors. This is the Streamlit Chat UI we are going to leverage, guys. We are going to use this, right? So please, give credit to them, and you can also use this in many of your Streamlit project. If you need a chatbot interface, you can just use it. That's what I'm going to use in my video as well. So this is for Streamlit Chat, and if you come back, we have some utilities like .env, base64, and then we have beautiful soup and request. Then we PyPDF, unstructured, tabulate, PDF. That's basically for pre-processing. We have to load PDF files, right, or docs, whatever file that you need to load it from there. This is the data that I'm going to use, guys. Let me just show you the data. So if I go inside data, there's a file. Let me just show you that file. I'm just going to open with Google here. So Google Chrome, and this data is the Q4 result of last year. Okay, 2022. Excuse me. So this, you can see that was published in February 2, 2023. So this is basically a report, quarterly report of Amazon, and that's what we are going to use. We are going to take this document, load it using Langchain, pre-process it using some character text splitter, and then we split that. Then we pass that splitter to an embedding model. So we are going to use OpenAI embeddings here. Okay, OpenAI embedding 002. That's what we are going to use for embeddings. Once we have the embeddings, we'll give that embeddings to Deeplake and say, hey, store these embeddings, because I'm going to use a language model to inference on top of it. And that's why we use Deeplake. which will help us with the embedding part of it, as a vector store or a database kind of a thing. And then we use language model or large language model in maybe for GPT 3.5 Turbo, for example, to create a simple chatbot that can retrieve the information for us, and we can ask follow-up question on top of it. That's what we are going to do in this video, guys, on this document. So let's start writing the code. So here I come and I'll create a file called app.py. So I'm just going to do app.py, and here I'm going to start writing all my code. So the first thing is import OS. Let me just import the utility stuff. So import OS and now Langchain thingy. So from Langchain dot document loader, document underscore loaders, and this I'm just gonna use import directory loader. So directory underscore loader, that's what I'm gonna use here. From Langchain dot document loaders, import directory loaders, and a couple of, let me just copy and paste, because I just created a video in my previous videos on. So I have a video where I have just created, so let me just show you. So this is the video that I created, my previous video, and I'll just copy the Langchain code, the data pre-processing code from here. So this makes sense. So let me just copy this character text splitter, paste it over here. This looks nice. Okay, character text splitter, and a couple of other as we need. So we need I think we need this entire thing here. So let me just copy this, and what else we need, I think for now this makes sense. So let me now start writing the other thing, the other import that we need. So from vector stores, let me see if I have some vector stores. I think I have pinecone. So in my previous videos I have used pinecone, but here we are gonna use Deeplake. So let me just do a deep and lake. So Deeplake, and this looks good. Now the Streamlit Chat. So from Streamlit underscore chat, and I'm gonna do import message here. So import message. I think we are done with the imports now, guys. So let me just do a load.env quickly, which is a, let me initiate this function, by the way, load.env, and we need couple of things here. So let me just copy this function. So this function is, let me explain this function when I paste it over here. What we are doing in this function is that we have a doc pre-processing. We have a variable called loader that kind of stores the data from directly loader. You can see our folder name is data, where we have our data of PDF file, and the glob we are using is a PDF. We are looking at the extension, then we only need the PDF, guys. We don't need any other extension or file format. We only need the PDF. And then we have show progress equal to true, and then we have docs variable where we are loader.load. We have character text splitter. We are having a chunk size of 1000, chunk overlap 0, just to save some time over there. Doc split text splitter or split document. So this is what we are doing with this function. Now I don't need anything from this, I guess. So let me just delete this, by the way, or let me just cut it now, for example, and Deeplake this. This also not required. This is also not required. Okay, this is required. Okay, now we have to get the API keys. So I already have defined my API keys in this EMB file. You can see it over here, and let me just show the format that it has. So os.environment and OpenAI underscore API underscore key. This makes sense, and here it will be os.getenv. This looks good. os.env, and then not OpenAI API keys. This is how you have to define in that file, guys. This is the naming convention that you have to do. So active loop underscore token, and yes, token. This looks okay. os.environment again, not active loop token. This is basically Deeplake account name. So Deeplake account name account. Okay, so this is done. So now we are done with our loading all this thing here, guys. So now this is successfully done. So what I'm gonna do here, I'm gonna also use a decorator in Streamlit. There are two decorators currently that have been used. One is st.cache data, and the other is st.cache resource. So let's do that. So st.cache The reason is because I don't want to run this function again and again in the same session if my data are not being updated. So you have a single file, for example in this tutorial video, and you have a session state. If you are not updating your data, why would you load this function again and again? That's why we need these decorators that will basically help us with cache that will help us cache or keep it in a cache memory kind of a thing. That's what we're gonna do. Now let's write the other function basically for vector store. So let's write that. So I'm just gonna write it embedding store or something. So embedding store, and here the first thing that we need is OpenAI embeddings. So OpenAI embeddings, this is okay. So now our embeddings are stored. Let's also print that so we can see that in terminal. That will help us bug it faster if we get any error. So print embeddings, and now the next is text. In that text, what I'm going to do here, doc preprocessing. Let's use the above function. So it will basically have the text stored into that, right? So text equal doc preprocessing. I'm just utilizing the above function that I have defined. Text are done. Now the db and deeplake. So deeplake, and in this deeplake, what I'm going to do here, so deeplake, I think that from documents. So if you have used Langchain ChromaDB, how do we write it? ChromaDB dot from underscore documents, right? So that's what we're going to do here. So from documents, deeplake dot from documents, and in this I'm going to just pass my text. So text and embeddings, and I'm going to pass my dataset path. And this is important, guys. This is where deeplake comes in. Dataset path, and our dataset path will be by default. Let me just show you. So by default, if you come back over here, create a vector store, click on this, and this shows you the step that hey, this is how you're going to create this Deeplake vector store from text data, right? And you already have given the code for Langchain OpenAI. I'm not going to use that code. I'm more interested in this path here. So let me just copy this path, and I'm going to minimize this. Let me just remove this, paste. This is what you have to do, guys. You have to copy that and paste it over here. Okay, if you want to give any other name instead this text embedding, you can give that, and that's the name, right, for your vector store that will be created in the Deeplake dashboard. So let me just show you. If you see here, AI anytime organization dataset, you will not see anything, but once I run this program, you will see a new creation of dataset over there. And that's the naming that we are giving here, text embedding. If you want to give it something else, for example video embeddings or audio embeddings or XYZ embeddings, you can also define that, and it will create if that does not exist. Now we have the db. Let also print the db, so we can just keep a track of it in the terminal. So print db, and the next thing is db and deeplake, and I'm just going to pass it over here. So in this we need some params here. So parameters, the dataset path. Let me just copy this thing here, dataset path, and dataset path, just gonna paste over here, comma, and read only. So let's have a read only, and it takes a boolean value. So I'll just write a true here. So true, read only, and then embedding function. So let me just write embedding underscore function, and I'm just gonna do embeddings in this case, embeddings. That's it, embeddings, and don't need that. So let me just do a return db here. Just return this db. Now this function is also done. Let's do a cache resource, not data, right? Because it has embeddings and everything, right? For example, or related thing that we have. So we'll call it not cache data. That will be cache resource. I don't want to use this dataset path and the embedding if I don't update my data. Okay, because embeddings are totally dependent on the data that you have, right? I don't want to call the function again and again in the same state of session that we are going to run. Okay, so this makes sense. Now we have returned db over here. Now what next I'm going to do? I'm going to write a function for search db where we'll use the LLM, guys. Okay, so let's do that. So in that case, let's define a function called def search db, and in this search db, here we're going to use our model, language model. So let me just do search db And the first thing that we need to call the above function, so embedding store, and keep that in a db variable. So let's call that db, and we need to define some args here. So retriever, so let me just call it retriever. I think I misspelled it. Okay, now we have retriever. So we're gonna do db dot as underscore retriever. That's what we do, right? So db dot as underscore retriever. Yes, this makes sense, as retriever. And we need couple of argument as well, or more than that. So retriever dot search quarks. So I'm just gonna do search quarks. Okay, and I'm gonna use the distance metric, and our distance metric will nothing but the cosine similarity. We are saying that, okay, hey, look, you use cosine similarity to find the similar vectors, and then give that to large language model so it can inference it and gives you the response. You have Jaccard similarity, you have Langchain, you have many other algorithms there, guys. It's very fascinating, natural language processing, right? That's what we used to do before ChatGPT era, right? With the semantic search. Now we used to work with this now, but Langchain does all the heavy lifting. These vector databases have default. That's why we use vector database. Why do we use vector databases? Because it has inbuilt, semantic search algorithms. It's faster. These are some of the USPs of using vector databases. For example, it helps you, embeddings in lower dimensional spaces and all, which is very fascinating, very intuitive to understand. Now in retriever.search quarks, the first thing that I'm gonna do a distance metric. So let me just write that distance underscore metric, and I'm gonna use cosine here. So I'm just gonna write cos. I'm gonna use cosine similarity, cos. I'll just copy this because I need this retriever thingy. So retriever, not search quarks, and then we have fetch k number. So fetch k, how many of you want to fetch, and then return me the best one. So fetch, it's end. So fetch, this is done. Let me just do a control, and then we need, let's have a marginal distance for subsequent vectors. Okay, so the marginal distance, or the that's not called distance, that's basically the relevance. So marginal relevance, maximum marginal relevance for that. So let's define that. So maximum marginal underscore relevance, and that, let's use, for example, it's a boolean value. So you want true or you want false to use maximum marginal relevance. For I will keep true. I want that to be happen. And now what else we can do? So let's have, so search quarks, let's have k, and let's keep this 10 for example for now. You can also play with these numbers, guys. So retriever dot, we have some search quarks. Okay, so we have distance metric, we have fetch k, we have maximum marginal relevance, and then we have k, which is 10. And our LLM comes in play now. So model, I'm gonna use chat OpenAI, and let's use model equals, for example, which model we can use, guys? Let's use Turbo for now. So GPT-3.5, let me see on big screen, Turbo, GPT-3.5 Turbo. So chat OpenAI model GPT-3.5 Turbo. This is our model. Now let's use the chain. Here it comes, retrieval QA. You can also use conversational, for example, but for that you need chat history defined. So model chat OpenAI. So let's write a QA. So in this QA, I'm gonna use retrieval here. So retrieval QA, and I'm gonna use not like that. I think it's from LLM. So from underscore LLM, and here goes some param. So model, and LLM equals to model, by the way, retriever. So let's define that so it helps you understand. Retriever, and I'm gonna use retrieval search quarks, not search quarks. Let's return source document equal to true. Return source document equals true, and this makes sense. True, and return QA. Now here I'm gonna use cache resource again. So ht.cache resource. This makes sense. So now we have three functions, guys. Let me just give you a walkthrough. Okay, so we have imported all the modules and APIs, right? And then we have functions, preprocessing, where we are utilizing Langchain. We are so dependent on Langchain now. Okay, I am more dependent on Langchain rather than my mobile also, I'll say nowadays. Okay, I love Langchain by the way. Okay, so we have embedding stores that's where we are using OpenAI embeddings, and then we are storing that embedding on the Deeplake. Okay, and we are utilizing that from there, and then we have writing of chain function. Okay, for retrieval QA we are using some quarks. Okay, the cosine similarity, number of fetches, get the best one, maximum marginal relevance, blah blah blah, and then we return the QA. Now let's write the Streamlit thing, guys. Okay, that's where we're going to write. So let me just call that and put in a variable. So search db, I store this in a QA, and I'll use this QA variable now everywhere now I want to use. Okay, so let's write the Streamlit code here, guys. Okay, so the first thing that I'm gonna do, I'm gonna use Streamlit Chat. Okay, with the history. So let's define a function that's let's call it display underscore conversation, and in this I'm gonna keep history for now. So display underscore conversation history. So for I in range, and let's have the length of the history. Length of the history. This looks nice, and but generated, and here let's close this. So we need, this makes sense. I think one is extra here, so this is okay now. So for I in range length history generated, that's a generated response in history. Let's use the message of Streamlit, that the message module that we have loaded over here. If you can see Streamlit Chat import message, and inside this message I'm gonna use history, and I will have a past. So like we have a generated, we'll have a past also. So past, and the first one of it. So let's, not first one, because we already have defined I. So let's write it I, past I, and is underscore user true. So if user is true, key, and that gonna string I, and what else we can do here, key plus underscore user. Now this is okay. So let's this is the user one, and we'll have a default one. So here we have the user one. So now again message, or maybe again, this looks nice. So future, it's not future by the way, that's generated. So generated, and this will be I, and key string, we don't need user true here, so just key. I'm just gonna pass string I. This makes sense. This function is done, guys. So we have defined a function called display conversation. Now let's write the Streamlit code. So define main, and in this I'm just gonna use ht.title here quickly. ht.title chatbot, or something like, let's have LLM powered chatbot. LLM powered chatbot. This is okay. And now here we'll have a user input. So user input, and it's a text area by the way. So ht.text area, I don't know why I'm not getting that suggestion. The IntelliSense is not working at this moment. ht.text area, and we'll have an empty one because that will come from Streamlit Chat. So I will not have anything here, but let's have a key for input. It will help us handle the state. So key input, and now let's initialize the session state, guys, right, for generated responses and the past message. So we have to initialize a session state in Streamlit. Very interesting. So if generated not in ht.session state, I don't know why I'm not getting that suggestion. ht.session state, so ht.session state generated, this is okay. And let's define something. So let's write I am ready to help, something like this. Let's write I am ready to help you or something. Now that will be welcome, like a welcome message there when the user types it something, right? I'm ready to help you. Now this is done. So let's have a past. So this is for generated one. Now we have a past one. So if past, and that will again be not in session state. So not in st.session state, and this, let me just copy this guys, right? So I'll just copy this and I'll change this I am ready to help, and I'll just write generated, not generated, that will be passed here now. So st.session state passed, and I'm just gonna write here I'm ready to help you, something like hey there or something. Okay, hey there. So this is done. Now let's search the database for a response. So the database, the vector database that we have, right? So if user input, if there's a user input, we'll have an output. So our output will be nothing but the QA that we have here. You can see QA search DB. Let me just see that. So QA, and inside this we'll have a query, and that's user input. That's perfectly fine. So we have an output now. Let's print that. So st.session, st.session state, and that's here goes the past, and then append that. So append that user input. So let me just do append with user input, st.session state, and then response, and then response is string. Let's have the output of its output and only the result. So result, now we're only going to in response, and I'm just going to show that. So st.session past append, it will not be passed, it will be generated now. So generated.append response. This looks perfectly fine. I think we are done. So let's display the conversation history, guys, using Streamlit message that we have from Streamlit Chat. So if st.session state generated, I'm just going to use generated, and here display conversation function that we have written on top, st.session underscore state. That's it. I think we are done. Let's have this if underscore name main. Let me just give you a walkthrough, guys. So we have completed our app, the code for the chatbot, by the way, and so very quickly all the modules have been imported, APIs have been loaded, Langchain heavy lifting has been done, doc pre-processing, the data pre-processing, looking at the PDFs, splitting it out. We have a doc split, contains that text. Then we have an embedding store function, loading the OpenAI embeddings from the module. We have doc pre-processing using Deeplake for the embedding. We have our dataset path here. You can see the path that we have created, right? The dataset path. And then we have DB Deeplake, etc. And in the search DB, we have defined some quarks there. You can see the distance metric, cause, fetch, maximum marginal relevance. We have our Langchain chain, retrieval QA. We are passing the model, passing the retriever, and also have return source documents true. We have display conversation, we have passed and generated. Okay, so I'll show you when I show the interface, it will be easier to explain. And then we have a Streamlit kind of a code here, right? User input, we have generated and passed, two different things, and then we are just playing around it. So let me just run this guys and show you what I'm talking about here. So how do we run a Streamlit app, guys? So Streamlit run app.py. You can see it's running, right? You can see the function that are running. So we have cached that, right? You can see, that's why you can see it over here, but you can also control that, right? If you don't want to show that on UI, let me open that terminal for you guys. You can see currently it's embedding loaded successfully. Let me just go back to dashboard here, and now you can see in real time text embedding for you, open data set. So it has been created. Earlier there was nothing on this Deeplake dashboard that you would have seen, and this is what it's doing. So currently it's running that function also. So let's let it run. Okay, now it will take little time because it has to do a lot of things there. It has to kind of pre-process the data, then create the embeddings, store the embeddings on Deeplake, retrieve the using LLM or whatever that we have right over there, GPT-3.5 Turbo. You can see it's still running, so the functions are running. You can see on the right hand side. If I come back over here, you can see it's creating for you the embeddings. Let me just click on this open dataset. When you click on the open dataset, you can see how you can also load it through a high level Python API that we have. This is your file path, the data path, deeplake.load, and you can see all your embedding thingy over here, everything, the indexes and all. So fascinating. You can also query it out. SQL query. You can see here, right? Text query language or what? So this is fascinating, right? It helps you, fine tune, serverless. It has version control. It has good features. Deeplake. I'll prefer this rather than Pinecone, for example, for now. Okay. So you can explore because it has audio embeddings as well. It has video embeddings as well. So you can create a multimodalities chatbot, a chatbot which works on across the data, right? So this will help you really do that. You can see it's currently running it. And now here we have our LLM powered chatbot. It says, hey there, I'm ready to help you. Okay, this is what it's currently showing. This is what we have passed and generated. So once you run it, you will understand it better. So let me ask, what was the revenue or something? What was it? Because it's an Amazon financial document or something, quarterly report. What was the revenue of Amazon? Let me ask this question. I have to press enter to apply. You can see press enter to apply. So when I hit enter, I should get my response, right? This is what we are doing. So let's do that. Amazon's net sales for the fourth quarter ended December 31st, 2022, were 149 some billion dollar, right, which is 9% increase from the same. We got our response, guys, right, using GPT 3.5 Turbo that we are using. Let me see if I ask any other questions apart, which is not in this document. If it gives me, I'm just gonna ask, right? I want to see if it retrieves the information from the base knowledge, because GPT 3.5 Turbo has its base knowledge as well. But here we have, created an embeddings on our document, our private data, a private document that we have. So let's see if I'm asking something else which is not there in the document, what kind of response that we get from it. So let me just ask it, what are the personal information, for example, OpenAI uses? If this is my question, I hit enter. Now you can also see the speed of response, guys, because it's not we are using the APIs there, right? So it's also be very fast. You can see, I am sorry, I don't have enough context to answer your question. Could you please provide more information? So basically it helps you, with the responses as well, because it does not give you any response which is outside of this document, which is very good, because we also have to look at hallucination at some angle. When we are working with large language model, it hallucinates like anything, but we can control that, right, with better embeddings quality, with better mechanism over there. So Vectra has a grounded generation technique. I have a video on that, how to control hallucination when you're creating this kind of application. So there are grounded generation technique that helps you with the more contextual responses, etc. You can have a look at that as well. So here, what are the personal? Let's ask some other question. Tell me. Let me open that document, guys. I haven't let me just do open with Google Chrome. I haven't gone through this document like that. Okay, net sales increase. How much? Let me ask this question. How much of net sales have increased, or something like this? I'm asking this question now. Okay, how much of net sales have increased? And for this interface, we are using Streamlit Chat, guys. I have already shown you. You can see it depends on which segment you are referring to. For the North America segment, you can see it's showing me step by step also, and also the geographies wise, right? So for the North America, for the international segment, for AWS, this is amazing, right? We getting good responses this is how you can build a smart chatbot, right? Using Langchain and with Deeplake and with OpenAI's either any services, GPT-3, 4, 3.5, whatever. Okay, this is how you can build it, right? And you can also customize this. Let me ask a question. Let me see. Tell me more about it. Something like this. I'm asking this. Okay. I just want to see what kind of responses I am getting. Okay. I'm sorry, I cannot provide more information without a specific question. The context provided covers a range of topics. You can see it's showing me because it's asking me to ask some relevant question. Because I just asked, tell me more about it. So what more about it, right? So it says Amazon financial performance, customer experience, employee benefits, and a lot of other things. Okay, tell me more about employee benefits. So I'm asking this now. Tell me more about employee benefits. Wow. So you can see it has that helps, right? The chat history that we have, the conversational memory that we call it. that we are using here, the chat history that we have defined. So Amazon offers a variety of employee benefits to its full-time and part-time employees. One of the most popular among them is the Career Choice Program, which provides employees with prepaid tuition for in-demand fields like healthcare, IT, transportation, and some others as well. This is interesting, guys. This is what I wanted to show you, how you can build a LLM-powered chatbot using Deeplake, which is now, I feel, it's very early to say that it's better than Chroma or Pinecone or whatever, but it works really good. It's open source as well. Excuse me. But it provides you with other features like it's easy to, it has version control, it helps in visualization. You can also visualize that. They have in Jupyter Notebook, I think, db.visualize. I can also show you something if it's available here over here. You can see here, this dataset can be visualized in Jupyter Notebook by ds.visualize. You can also use that. This is fascinating to work with. So I hope you learned something from this video, guys, how to use Deeplake, Langchain, and ChatGPT or GPT 3.5, for example, to create this powerful chatbot. Okay, you can also extend this. The code will be available on GitHub repositories. So, and the document, you can upload multiple documents. You can create something like investment banking GPT, finance GPT, fin GPT, sports GPT. Whatever GPT you want to create, you can create using this kind of technology. It's not rocket science. Anybody on internet can do it. You just need the internet there, or even without internet you can do it. If you want to utilize open source models, like you want to use llamas, alpacas, vicunas, etc. model, you can also do that. With Chroma DB or Fast CPU. I also have videos for that. Please go through, watch some of the videos that I have that I've created earlier on those. So I hope you like this video, guys. So this is what I wanted to do in this video. I hope you learned something from this. If you like the video that I create or the content that I'm creating, please consider liking the videos. Please hit the thumbs up icon, and if you haven't subscribed the channel yet, do subscribe it. Please share the video and channel with your friends and to peer. That's all for today's video, guys. See you in the next one.